Welcome, class 9 physics. Today we take up the second part of the same chapter of motion chapter, that is graphical representation of linear motion. This speaks about the graphical way, the way that it is described in graphs. It is a pictorial representation, a diagrammatic representation. So, graph is a scientific diagram which is plotted in a frame with the axis, that is x-axis the horizontal line, y-axis the vertical line. These two axes, they are the axis. Normally we say horizontal one as x, O as origin, and y-axis the vertical one. So this says x and y-axis. On x-axis we take such quantity which is independent, which is free, which is not depending on any of the y-axis value, and y-axis quantities are those which are directly depending on the values of x-axis. So x is independent and y is dependent. That's why it is x and y-axis. That is a general concept. Any measurement will take from O, that is origin, rightward to O, all are positive numbers, positive quantities on x sides. Upside of that on the y direction, that is all positive quantities. Left side to x will be the negative quantities. Downside of y is the negative quantities. So here we take up that as a first quadrant only, that is the first right angle part, that is on the right side. We find that it is x and y axis. Now we have given a name here, the quantity like displacement and time. Since the first word is the y axis, normally taken the first name of the graph quantity is taken as the y axis value. So this is your displacement axis. This displacement will be increasing upward, and time will be the x-axis. Therefore, because time does not depend on anything, time is a free quantity. So it is simply to say that displacement is depending on time, but time is not depending on displacement. So displacement time. Now this chapter begins with the displacement time graph. We will plot all the values of the displacement values along the y-axis, and all that will be plotted in the time on the x-axis. That way, time can be divided according to our needs and choice. It can be 1 second, 2 second, 3 second, 4 second. It can be 5 second, 10 second, 15 second, 20 second. It can be 2 seconds, 4 seconds, 6 seconds, 8 seconds, but it will be always a uniformly spread. Accordingly, the displacement value will also be equidistantly placed on y-axis. Whatever necessary values we require will put on the displacement axis. That is the concept that we start. Now, displacement and distance will be taken here in the graph the same, because it is one dimensional. That means it is only having a straight line motion. In case of a straight line motion, there is no change in directions. That's why it is having no differences over here, as the scalar and vector quantities are such, as distance is a scalar quantity, displacement is vector quantity. Yesterday we did it, but here the displacement and distance will be taken same, because we are taking as its one linear motion, or in a straight line or rectilinear motion it is. So both the same axis will get for displacement and distance. So I am taking displacement word name here. It can be distance also. So will be speed and velocity as well. So at times we see, say I'm taking 1 second, 2 seconds, 3 seconds, 4 seconds, 5 seconds, 6 seconds, like that. Displacement I am taking, say, as 5 meter, 10 meter, 15 meter, 20 meter, 25 meter, 30 meter, 35 meter, 5 meters gap. Now, if a body takes a move in such a way that at certain time, at 0 time, it takes a move from 15 meter displacement, it moves straight along parallel to the time axis. That means at 1 second the displacement, at 2 seconds, at 3 second displacement value 15 meter, 4 second displacement value 15 meter, means displacement remains same over a period of time as the time passing by, but the body is not moving from its distance, which is it is recorded at 0 time. That means body is motionless. It is making no displacement here. That shows that body is stationary. It's stationary. That means when graph line comes parallel to the time axis, the motion as such is 0. That means body is very much in the stationary condition. Then, if the displacement and time are taken in different order, say displacement, if it is above the x line, x axis, they are positive values. If it is below the line, if the graph line was below, this displacement value would have been negative. Why? Because y-axis value upside from origin is positive, downside of origin is negative. So the displacement being a vector quantity as such, it will be the negative value also could be taken here, as it is -5, -10, -15, -20, -25, like that. It can go like that also. So if it goes parallel to time axis, it is motionless. Second way, one second body moves 5 meter displacement, 2 second body moves 10 meter, 3 second body moves 15 meter, 4 second body moves 20 meter. Like that, when you draw the graph line, say graph line is moving just by the points which you have joined, and that is moving up. So I name this graph, say, as A to an point B. So AB straight line says it is inclined over the time axis. So this angle is taken in the leftward here. So this is the slope. This angle is the positive direction. So this angle is giving a slope to it. So the angle value whatsoever, if it is a bigger angle, the value will be high. If it is smaller angle, value will be less. What value? The thing is that if this AB line, I select a point, say up to 30 I drew, I select a point P over here. I select a point Q there. Then we find the slope out of it. Slope. For finding slope, we have to come to two terminologies quickly. One is slope, means slope stands for ordinate divided by abscissa. These are the mathematical terms. Ordinate is the length which is parallel to the y-axis. Ordinate, the length parallel to the y-axis. And abscissa, any length parallel to the x-axis. So this length will be abscissa, this whole length will be abscissa. Any short length between that which are coming parallel to the x-axis called abscissa. Thus ordinate is one that is parallel to y-axis. For slope directly we use ordinate divided by abscissa. So here you will say ordinate value is PQ, so it is PQ divided by AQ. Now you can find what P, the maximum value at P there is 30 meter minus the lowest value of Q, that is 0, that is 0 meter, divided by what is AQ. From A to Q, last point is 6 second minus 0 second. This is the slope. This slope is 30 minus 0 will be 30 meter divided by 6 minus 0, 6 second. Obviously this will give you 5, so this value comes 5 meter per second. Now what is this quantity coming then? If it is the value coming 5 meter per second, 5 is magnitude, 5 is numeric value, and meter per second is the unit. This unit describes what kind of physical quantity you got from the slope. Meter per second is the unit for velocity or speed. Since it is displacement, so this gives you the velocity value. Therefore velocity is equal to 5 meter per second. The body is moving uniformly with 5 meter per second. Then how we say it is uniformly? How it is uniformly? You cut off any section. Say I take another point, say LM, length of abscissa, that means 2 second time, and the last is the 6 seconds time. In between that, what is the slope here? If we find the slope in the triangle, if we find the slope for triangle PLM, come over here. This slope will again be ordinate by abscissa. This part is ordinate, that is PM, divided by abscissa will be LM. P value maximum is 30 meter minus this is 10 meter line of PM. So it is 10 divided by time is 6 second minus the time is here 2 second. What value is there? 30 minus 10 is 20 meter. 6 minus 2 is 4 second. 4 5 is 20. Again it comes 5 meter per second. This shows that it is a velocity. This is the velocity.